I'm right here. I just walked past you.
So he's already here. That's the videographer and photographer. Oh, okay. So he's already there. So you can coordinate.
My long time ago, I mean like last year. I don't have time. Seriously? Yeah, I was asking about the AC.
It's his brother. Canon 5 It's a still
The cavalry is here.
He's like, it's good. They got a real video.
Yeah, this is my brother.
Remember what deal? You remember covering arm and exhibition and make sure when I stand there, you start to fix it. So don't mind what they're doing their own stuff. So you do your own.
Yeah, y'all are independent.
Yeah.
Y'all are.
Make sure you take really good photos of both of us. Okay?
Yes, there is. Mark with the black shirt. No, he's the one who designed it. But it's okay. He's just here. He's here. Yes, he's just showing. Also, I'm saying Fidel is a lot nicer.
Photographers. How are you? I know this guy. Put her here. He's at school.
Yeah, no, feel free to sit wherever.
Yeah, cool. We'll just,
I'm gonna get out. I'm gonna be out.
how you feeling about everything?
It's going way better than I thought. This, yes, that guy's doing people. This is people. So this needs to happen. Yeah. We got a real friend, and my parents are here. It's family weekend, so they showed up. I didn't even know they surprised me. I wish you. Good for them. You don't want to pay them either. Huh? They're paying nobody. These guys are doing it from the school. Yeah, no, they're on like a salary. I should believe it. There's a bunch of them. These are the I'm not too worried about it.
Howdy, excited to be here today. Okay, we're about to start in like 1 minute, so if you're outside the exhibition, please, last to make it ready. We're expecting a lot of attendees, and yeah, we'll just start and then we'll join us because the schedule is a bit tight and want to get the ball rolling. Okay, just 1 minute here. I'm waiting for them to come in, so you can continue the talking here. I guess we'll just start. Okay, sorry. Howdy. So my name is Fidel Makatier. I'm a PhD student here. I work at Mixed Signal Group, electrical engineering, obviously. I'm honored to have you guys here. Welcome to the IEEE Semiconductor Conference, Tech Standard Semiconductor Conference 2025. We're expecting a lot of people, so don't feel afraid if you see the whole room packed. That will be normal today. So yeah. So it's my pleasure to announce the conference committee that made this possible. Myself, Fidel Makati, served as the conference chair. Sharon here also was the conference chair. That's how important the conference was. We had to have two conference chairs just to make it possible. So we had Akshat, who served as the technical director. We had Steven, who served as the operations director. We had Gita, most of you already know, served as the hospitality director. We had DPJ, the finance guy. We had Oliver, who served as the PR guy. So if you see our cool PR, he was the one in charge. We had Seth. We had Aju and Nafi. We have a lot of volunteers, so we couldn't fit all of them in the slides, but at the end, Cheryl is going to call their names at the end of the conference. Yes, so it's a joy to host you guys, and to all our partners and companies that are around. We are so honored to have you guys. Yeah, and we expect it. We'll be listening, we'll be taking notes, we'll be networking as much as we can. Yeah, thank you so much.
Howdy.
Howdy.
All right. Good morning, everyone, and welcome to the 2025 IEEE Texas A&M Semiconductor Summit. Woo! We're so excited to have you here today, a gathering of brilliant minds, passionate engineers, researchers, industry leaders who are shaping the future of semiconductors. Before we dive into our incredible lineup of speakers and panels, I'd like to highlight one of the most exciting parts of today's experience, our exhibition fair, located right on the terrace, so make sure you stop by throughout the day to see the latest technologies, student projects, demos from our partners and sponsors. It's a great opportunity to connect with companies and researchers who are pushing boundaries across the semiconductor space. Now, for a few housekeeping items, please silence your phones during sessions out of respect for our speakers and guests. Keep voices low in the hallway, outside the auditorium while sessions are underway. During keynote presentations, the side terrace entrance will be closed, so please use the main entrance at those times. Restrooms are located just outside this room to the left, and we ask that we do not crowd the exhibition booths. Also, be sure to stop by the photo booth outside. I'm sure you saw it on your way in here. Snap a pic and tag us on Instagram at IEEE_TAMU and share your experience with us with the hashtag Semiconductor Summit 25. We'd love to see your moments throughout the day. Our team is here to ensure a safe, respectful, and welcoming environment for everyone. So if you see any misconduct, please come to anyone with a summit badge and let us know. And in the event of an emergency, remain calm and follow directions of event staff. Emergency exits are clearly marked and volunteers are stationed throughout the venue to help. Finally, for your reference, today's event guide can be found on the conference website. Additionally, as Aggies, we represent Texas A&M and the Aggie core values: respect, excellence, leadership, and integrity. Let's remember to carry those values with class, lead with hospitality, and show everyone the spirit of Aggie Land is all about. And finally, if you haven't already, take a second to introduce yourself to the person sitting next to you. This summit is all about connection and it might just spark a friendship or future collaboration. With that being said, it's been an honor to put this event together and seeing our vision become a reality. We sincerely thank you for being here, and we hope that I hope you enjoy every moment of this experience. Thanks again.
I'm already excited. Okay, so because of time, we're just going to start. It's my pleasure to introduce our branch advisor, Professor Stavros. Yeah, professor of practice, a lot of years of experience in Intel, building research, and also the associate Eastern department head. Thank you so much.
Howdy. Earlier I was talking to a couple of you trying to figure out, how did we get the crowd to silence? And I said, well, it took me a couple of days when I first got here to figure that out. But it was pretty easy once the students came up to me and said, just say howdy. I said, that's the word. I said, yeah, just try. And I did. It worked. It's like a job. It worked all. You get tired of hearing it, but that's So, as you found out, my name is Stavros. I'm the sponsor for the IEEE chapter. I'm amazing group of students that put together. I'm also associate department here for electrical computer engineering, professor practice. But as you can tell from my age, I've only done this for 9 years, right? So clearly I've been doing something else for the rest of my life. So I spent most of my life with student director. So semiconductor is dear to my heart. As you can see here, by the summary of it's a pretty large conference, varied backgrounds from all over Texas. That's really nice to see. Texas is a state, post-COVID, has really been the recipient of a lot of funds. Some of these are government-based funds, such as the CHIPS Act, for example. And between those government-based funds as well as industry investments, we're talking about billions of dollars that have come into the state in the semiconductor manufacturing area. This provides a great opportunity. So this summit really capitalizes on that opportunity in enabling us to meet each other, talk to each other, determine how we can collaborate, and determine how we can really make successful all that money that we're investing in the state of Texas. We don't want to squander it, right? So what I want to do next is to thank our key sponsors and exhibitors. And I'll go through them in a list because without their help, we wouldn't be able to put the conference together. I've spent the last couple of weeks approving expenses. So this means I've put everything together, but all of those expenses take money, and your help was what made it possible. So Texas Instruments, ARM, Micron, Keysight, Cadence, Infineon, NASA, Falcon, the ECE department, thank you very much, and IEEE USA, as well as the Texas Semiconductor Institute, which is housed up in the Morelos campus here. Finally, and I would say most importantly, before I get to the last slide, I wanted to reach out and thank the IEEE student TAMU chapter. They have been very creative. They are the ones that actually came up with this idea. They came to me in about the end of January, beginning of the semester really, and said, we are thinking of putting a summit together in semiconductor manufacturing, semiconductor area. What do you think? And I was ecstatic. I thought it was a great idea, very supportive of what they wanted to do. But pretty much they did everything themselves. Just checked in on any questions they had, but they did it all themselves. So I think what they deserve is a strong applause for whatever they did. With that, I'm going to pass it on to Infineon, who is going to come up next and give it.
Thank you, Stavros. So let's try this. Howdy?
Howdy!
Woo! All right.
It's great to see that my Texas accent is working really, really well. All right, my name is Gregor Guest. I'm from Texas. I'm from Austin, Texas. Apologize for that. I'm the head of product marketing, microcontroller at Infineon. So you might be wondering, who is Infineon? Actually, we know who is Infineon in the room. Wow, awesome. Infineon is a German company. We are the number 8 semiconductor company in the world. We make $16 billion revenues per year, and 50% of our revenues are made in automotive applications. We are actually the number 1 automotive supplier for semiconductor. In Austin, Texas, we mostly do microcontrollers. And when I've been invited to come here, this colleague, actually my colleague who's also in Austin with me, also ex-Semiconductor. We're like, what can we really talk about to students that's going to have an impact? What I want to talk to you about today is about Edge AI and why it's important to you. You hear a lot about AI, but Edge AI is really important because we're seeing really a shortage in talent. So at Infineon, we really struggle to really hire people in Edge AI, even though we are the leader in that space. So we thought we would kind of give you an introduction about what Edge AI is, give you some examples, but also what Colin is going to show you after that is what one of our interns has been doing at Infineon. That's pretty spectacular, that's pretty interesting. So what is Edge AI? I think I need to introduce the concept of Edge AI. Whenever you hear about Edge AI, generative AI, NVIDIA, right? Everybody knows about that. It's everything that happens over there, in the cloud. You send data, you have sensor, you send data to the cloud is going to do some compute analysis, whatever, and it's going to send back some data and some information. That's what people think about AI, the big trendy world right now. Edge AI is actually, the way I phrase it is more like intelligent sensing. It's actually the capability to make a decision on the spot. If you look at my LinkedIn, I put the post on it explaining what Edge AI is, and I say why actually our microcontrollers with neural processing unit are making decisions on the spot. Wi-Fi is still transmitting data. And this is really important for several reasons. Because first, you're gonna have better latency, better performance by making a decision here. But also, if you think about it, with AI happening, we're gonna be using so much energy that the capability to move those decisions at the edge is gonna really reduce the power we're gonna be using that for. Why is it important? Because at Infineon, we are committed to decarbonization and digitalization, so we are a very sustainable company. So for us, it really matters to have an impact on that space. All right. So with this being said, let me move to. Yeah, this is it. Let me move to the concept of how Edge AI can be applied to industrial IoT. So the first thing is I want to introduce a term here, IoT, Internet of Things. Are you familiar with that? All right. Okay, very good. IoT, industrial IoT. So IoT applied to industrial application. And then there is AIoT right now. I don't know if you probably heard about that, which is basically Edge AI or IoT. This is what I'm talking about earlier. Well, what I'm going to be talking about today is AIoT. So that's a new concept. So put this on your resume, you're going to have a lot of attention. AIoT. All right. I'm not going to comment on this. You can read faster than I speak, and even though I speak fast, but I will let you read on this. But this is exactly what it is. It's about intelligent sensing and being able to make decisions on the spot. Okay. Why it matters? It's a massive market. So in 2022, the size of the market was $544 billion. By 2030, it's going to be a $3.3 trillion market, which is a 25% CAGR. So I hope you have quite the concept of CAGR on the marketing guide. So 25% CAGR, compound annual growth, is basically saying that every year it's going to be growing by 25%, which is massive for us in business. So I don't know if you know a lot of markets that grow 25%. I don't know a lot of them. I don't want to say I don't know the tariff to have a lot of growth like this, but I didn't. I didn't do that. So this is really a market that's important for you, and that's why I really, really tell you, pay attention to this market, because there's going to be massive opportunity. And as I was saying to Charles earlier, there's going to be very, very high salary in this industry. There's going to be opportunity to make a lot of money.
You're blocking the view. No, it's okay.
All right, some key data when we talk about industrial IoT. 5 to 20% reduction in plant's productivity because there is a misfunction in the equipment. Every year, 3 over 100 of manufacturing employees experience a working injury annually. So 3 over 100 might seem minimal. Yeah, it's not a lot. But let me ask you a question. Who is left-handed in the room? Raise your hand, please. Are you left-handed? So 3% of the population represent the left-handed. So everybody in a factory would, it's like you would be telling before, everybody who's left-handed in a factory, you will get insurance here. So that's to give you some concept about the way. And then finally, where there is a big impact, on the IoT, is the cost of downtime. Whenever you're in a manufacturing plant, whenever you're manufacturing product, the overall cost of downtime when the machine is not functioning properly is $50 billion. $50 billion overall. So $50 billion for you to remember that number, that's the GDP of Bulgaria. Or that would be like buying an iPhone for every people who lives in Germany. So pretty massive number, right? All right, now what I'm going to do is I'm going to show you really 3 examples where Edge AI is being used for industrial IoT and the benefits of using Edge AI. So I'm not going to spend too much time on this, but just to give you an idea, this is the different layers you have in the manufacturing plant nowadays. The way it's organized, from basically sensing at the equipment level back to the cloud, where you get the data being stored. And so when you're going to be using Edge AI, and remember that's why I introduced at the beginning, Edge AI is making decisions on the spot. It's like having a brain on your sensor and being able to make the decision. Okay? One of the things that's going to be really important, you're going to be able to make fast decisions. And why it matters? It matters because when you're in a factory, everything that's related to control has to happen really quickly. You cannot control the equipment and say, hey, I'm going to have some latency, I'm going to have some delays between the command and between the execution. So having a smart brain on the sensor here, being able to make a decision on the spot, is going to really improve the performance of the equipment. The second point I want to talk about here is the predictive maintenance. So the predictive maintenance, I don't know if you're familiar with this, but basically it's the concept of being able to analyzing some parameters with sensors on an equipment and predict that the equipment is going to fail or predict that the equipment needs maintenance. So the way it works nowadays, we're basically measuring vibrations. If you're looking at the motor, we're going to be measuring vibrations. We're going to be measuring temperature of the equipment, or we're going to be listening. Sound is really important as well when you have an equipment. So I'm going to break it down for you. AWS has amazing predictive maintenance. So they really have those models trained, in the cloud that can really do all the analysis and tell you if an equipment is going to fail. Which is great because you can go on the equipment and just fix the equipment before it actually fails, which prevents the $50 billion, the GDP of Bulgaria, downtime that we talked about. But what you're going to be able to do, the problem when you do it in the cloud, you have to transmit all those data, the vibrations, the temperature, and the sound into the cloud for analysis. When you're using Edge AI, you're going to be able to actually filter it at the edge. It immediately responds to it. Don't forget, the decision is made on the spot, immediately, with no latency. So if an equipment is about to fail, you're going to be able to make that decision instantly and to stop the equipment, protect the equipment, and reduce your downtime. So massive upside for industrial application. I'm not going to talk about the other points because we're limited in time and I know you can read all of that. And I'm sure those slides will be available, but I think you get it, right? The second example I wanted to talk to you about today was quality equipment. So there was a German car maker, automaker, that issued a record for 270 vehicles in the US because there was a bad welding on the braking system. So 270 cars, it's not a lot. But still, when you are a German brand without the reputation and the big name, the cost of those cars, this is a problem. And we're talking about the braking system, which really affects your safety. So this is another area where we see really AI doing some wonders, and that can really improve the system. And we talked already about downtime, we talked already about predictive maintenance, but I want to talk about 2 key points here. At the beginning, I introduced the fact that it's really important to be sustainable as a company, very important and resilient as we focus on decarbonization and digitalization. One of the big benefits when you do edge AI for welding machine is you can significantly reduce the material waste. Because you're going to be optimizing every component, every material you do the welding. So this is really using less material and improving basically the quality of your welding when you're performing those operations. Of course, the quality of the welding will be much higher because the system is capable of learning and adapting to all parameters on the spot. There is no need to go to the cloud. You just make the decision there. And as we're talking about no cloud dependence. So no cloud dependency can be important in the factory because when you're trying to connect to the cloud in factories, sometimes you actually have some dark spot, some area where you have no coverage. Think if you're using wireless. I think an easy comparison for you would be to think about Wi-Fi, right? When sometimes you are in your house or sometimes in a new building, you don't have Wi-Fi, you don't have access to Wi-Fi, so no access to the cloud. Well, that's pretty similar here. Let's imagine you have some area in the factory where the connectivity is not available. You will still be able to make decisions on the spot. Okay? Finally, the last example, I actually really love that one. It's about the forklift in the US. So, 1 in 6 workplace deaths involve a forklift in the US. Do you know about that? That's pretty amazing. So, there's a really good video on YouTube. Unfortunately, I couldn't make videos today, but there's a really good video. I invite you to Google this, where you will see a guy falling asleep on the forklift in a warehouse, and he basically wrecked all the shelves into the warehouse. Well, this is a disaster. For there's the cost, but then there's also the impact. What if he's going to be beating somebody or those ways? So really big safety concerns. That can be solved with AGI. So let's talk about this quickly. When you have AGI and you are capable of making decisions on the spot, let's think about it like having vision on the equipment, and you're basically going to be able to spot what's around you. So with AGI, we are really capable to have vision and detect shape. You can even say if it's a human, if it's a dog, you can say if it's an object. You can classify those objects. So you're going to be able to, even if some people fall asleep driving the forklift, to identify there's a shelf and either brake and stop the equipment, or avoid the people or whatever, the shelves. So that's really this kind of intelligence you want at the edge, to be performant. Another impact of the edge AI is the capability to respond also to new routes into the warehouse, because the system becomes smart and everything can be optimized, which also is going to be leading to using less gas or using less battery. So again, I know I'm kind of very involved in sustainability and I'm very concerned about that. That's a big thing I need to do, as I mentioned. But that's really optimizing also how much energy you will be using under those conditions. And eventually, what we're going to be leading towards, because as the edge AI is becoming smarter and smarter, we are thinking forklifts are going to become autonomous. So basically, you're not going to have the issue with the human support in that case. Actually, if you look at the warehouse from Amazon, they already use those robots who are just basically very intelligent and go and pick everything. And they never collide into each other. They never hurt each other. And that's basically because they have the capability to make instant decisions on the spot, like you want to be doing on your car when you're driving, except they are much faster. That would be the difference. So this is it. I wanted to basically just really, my goal today was to really let you know about this opportunity for edge AI. We're going to have more technical presentation later. But I want you to really understand what's the opportunity. I wanted to show you 3 examples that I think are really relevant. The application in robotics, the application with forklift, the application with welding. But this is not the limit. With edge AI, we are becoming incredibly more and more intelligent, and especially we see a lot of cases around vision. Think about quality and default check, for production. You're going to be able to really inspect. And the edge AI is going to be able to really separate the good parts from the bad parts. Amongst the other applications we are seeing is edge preparation, with basically keyboard detection or natural language at the edge AI. You're going to be able to basically pass code without having any interaction. The future of human-machine interface is actually both. That's you're just going to be talking to actually working on other applications like smart thermostat. So when you're on your own, isn't that a pain to actually set up your smart thermostat and all the schedule and all of that? What if you could do it with your voice? Just go to your voice and just say, hey, engineer, can you set up this my thermostat for I don't know, 72 degrees from 10 a.m. to 4 p.m. And just adjust to it without having to do anything. Of course, you can do that already with Alexa right now in your home. But again, this is a combination that goes back to the cloud. And if you don't have Wi-Fi connectivity, so that's one of the things I want to talk about. One last thing we are doing also with Edge AI is actually user ID and identification. Basically, we're going to be able to recognize when somebody talks or recognize the face of the people, not in your own. Because it's not authorized yet. But we're going to be able to video authenticate the person when they approach the equipment and be authorized to use them. So that's also a big point. All right. So finally, I just want to give you a little speech about what Continuum does. We have created this product that's called Resource Edge. That's made of ARM cores, Cortex M33, Cortex M55, and the neural processing unit U55. That's where you compute all the occurrences at the edge. We provide the hardware, but we also provide a complete solution in terms of software. And I think for new engineers, that's really important to understand that. I know it's a semiconductor summit, but I'm going to break it out for you as a marketer. Honestly, the hardware is really not the most important part right now, especially in the microcontroller industry. The software is everything. And the reason for that is because the cost of developing software on those microcontrollers is incredibly expensive. So being able to use software is really critical for our customers right now. So really providing those turnkey solutions is not only about the hardware, it's also providing the software. And on top of that, Infineon is a company, for a company called Imaging Hub, where we can actually provide the ML models, machine learning models at the edge directly to our customers, so complete solution. And last but not least, something I want you to take away as well is everything you're going to do related to AI requires a very high level of security, because every model you're going to develop is IP protection. So you have a unique opportunity as making product or manufacturer to differentiate against competition by leveraging machine learning and AI. But if your models are being acquired by the competition, you're basically using your advantage and your edge. So that's why all our products come with the highest level of security to protect the models from our customers. All right, so this is really my takeaway from this. I'm not going to go into details. I'm not going to tell you more about Infineon. We're a great company, by the way. So apply to our jobs or apply to our internship. But I hope you will be sensitive to Edge AI. AI is not only about NVIDIA, it's also about Infineon. And buy our stock, yes, we need it. And thank you very much for your attention. And now I will introduce you to Pauline, who is our head of application engineering at Infineon Ancien. And he's going to show you what interns can do in our team. Thank you very much.
Howdy. Howdy. All right, get started. I'm going to take you through a real-world application of this technology. It's a project that one of our applications engineering interns did in Munich, and it'll give you like a pragmatic use of how these tools work. So if you look on the right side of the slide here, it shows the system with a microcontroller that says it's included with compute and the AI algorithm, a power stage driving the motor, and with current sensing is providing feedback. Okay, that's the sort of frame of the system. And the way that this intern built this project is you have to collect the data and train the model. And steps, individual steps are broken out here. Collected a bunch of waveform data, labeled it, built this data set, and then trained it. And we actually provide these tools. So Infineon has a studio of ML tools that we offer from our acquisition of a company a couple of years ago. It's referred to as our Deep Craft Studio. Then you deploy the model onto the microcontroller. Again, this is all using our Deep Craft Studio. On the system, then, once it's running, what it can do is it takes the current sensing information and it can, at the edge, real time, detect if the motor is out of balance, for example, if the load is out of balance. And real-world applications about this would be things like in your home, a washing machine, if the load is out of balance, when it spins, it will oscillate, and if it can automatically detect that, it could either alert you or take some other preventive measure. In an industrial application, it could be a wear issue, a preventive maintenance issue, for example, and at the edge, these things could be detected just using the current sensing. This doesn't require additional sensing elements in the system, so it's pretty cost-efficient approach as well. Okay, so the high-level model that you developed, the high-level how it works is really just a transfer function. I bet a lot of the WE students here know exactly what that is. And what you want is you want data to go into the transfer function, and you want the model to make a determination or label of what is happening in that data. So here's the example of the raw data, the three-phase currents of the motor. And by looking at those waveforms and training the data set to see the patterns of the data when the motor is out of balance, you can then label the data, and these will be the determinations that the model will make. Here's the actual photograph of my intern's project. You can see you just used an Infineon motor control evaluation kit with a simple motor and some weights applied to one side to make it out of balance. Very straightforward, thing for him to build up. He imported the samples on this evaluation kit and put them into the DCraft tool. That tool was also then used to label the data, train the model, build the model, and then with our Motos Toolbox software that we use for developing code on microcontrollers, it was then deployed into the device. So it's very straightforward when you back out a little bit from this stuff. And I think this example does a really great job of showing like, oh, again, this isn't actually black magic. This is actually, it is a simple example, and it's an old example. People have been talking about, preventive maintenance on motors using machine learning for a long time. But I think it's a great example, and I think it's also really cool at an event like this with a lot of students to show that a college student can use this technology and really get some good experience understanding it. So I hope you enjoyed the quick overview of a real-world use and how you can actually do this. And a lot of companies are coming out with more user-friendly tools. At Infineon, we're really trying hard to make software tooling powerful but usable. And I think in the future it's going to be really exciting where people can quickly build machine learning models. I think it's going to be really an interesting time. Any questions? So I think we have a couple of minutes for questions still. Okay. Oh, there is one. Great.
Hi, I'm Love Hassan. I'm the incoming president of IEEE for Caribbean University. And my question is on your sustainability side. So what are you guys doing to kind of mitigate how much energy AI is using with data centers and things of that nature?
It's a great question. Gregory would love to answer. I'll make a point. And, we're focusing very heavily on machine learning at the edge, which doesn't require a cloud connection. So it absolutely is a lot more power efficient to make machine learning decisions at the edge. You don't have to make that decision in a data center, which is absolutely highly power efficient.
Thank you for asking. I didn't pay her, but I want to answer that. So actually, I'm going to be giving a webinar on these topics. Infineon is really helping with sustainability. So there are two angles I think we're really helping. Number one, like Colin said, we want to move edge AI, AI to the edge and do as much as we can on the edge. I still believe there's going to be connectivity to the cloud, honestly. I think that's going to be connected edge AI. but we're going to be able to offload a lot at the edge, so we're going to be using less computing to the cloud, less energy. That's the number one thing. I think it still raises another problem though, is what are we going to do with all the batteries from the IoT? So I've been really looking a lot right now from a marketing standpoint into ambient IoT, which is basically leveraging energy harvesting, like kinetic energy, PV cells, or even temperature gradient to actually produce energy and replace batteries. So that's the number one thing. Now the second thing you need to know about Infineon is we are actually the worldwide leader in GaN technology. And the GaN technology for power reduces actually the power used in data center by 20%. So of course this is not really replacing all the power, but this is a step in the right direction, and step by step together we can actually fight for sustainability. I think this is important. And maybe if I have 1 more minute, one thing I want to add to you, I had the opportunity to meet the CEO of Schneider. And when I met with him, he made it very clear that Schneider is the #1 sustainability company in the world. So this is a model, this is the blueprint for everybody, right? And when he was saying, when I talked to him, he said, now we're going to be grading our companies on their level of engagement in sustainability. So the greenwashing is happening, but this is also by driving those kind of requests at the superior level, and we're all going to be able to really improve our sustainability. So I think it's critical to do those words, and I'm very happy to work with engineers on that.
I think we can do maybe one more question.
Howdy, my name is Zane Hafiz. I'm a first-year engineering student. My question is, what would be the cost of application for this in an industrial setting, just on a general level?
Cost. Cost, I better let the business guy talk.
So that's a good question. I can tell you, I can give you a marketing speech. Are you going to buy it? Are you going to buy one of those piece of cash on my phone? So here's what's important. You have 2 ways to do edge AI right now. You can use an NPU, the microprocessor, or you can use a piece of edge, the microcontroller. If you're looking at NPU are going to be running Linux, or they're going to be running Android. They require really massive memories, you know. I'm talking about several megabytes of memory for the code, you know, and for the data that's going to be stored, and you're running massive operating system, right? The cost of the NPU are going to be like $7 to $10, right? You need to think about it in terms of cost, and then the memories are going to be like $3 to $5 for those kind of things, right? When you're looking at a chip like a piece of edge, we call it actually a crossover NPU. So it's a microcontroller that's going to come with embedded memories and all the peripherals. They're not going to be running Linux or Android. They're going to be running FreeRTOS. They're going to be running Zephyr, or they're going to be running bare metals, direct C code, right? We're going to be looking at something maybe more like performance. So what we are seeing is right now when we're doing crossover versus NPU, we can add the price in terms of BOM, but we're also twice the performance in terms of differences, thanks to our friends from ARM, actually, who have released a really good neural processing unit, U55 and U85. So we're using less power. Like sustainability, we need to use less power, but we are having better performance because we have a dedicated computing unit for inferences. Over.
And we do have time for one more question, by the way, if anybody has it. Oh, here. I'll get you a mic. Back there. I saw you first.
Hi, my name is Gustavo. I'm a graduate research assistant at Trinity University, and fortunately my research domain is Edge AI. So at my university we conduct research on NVIDIA hardware. So we try to measure the capability of those small scale factors hardware. So I'd like to be interested to know that have you ever done any kind of I mean, how much big model have you implemented on your devices? How good they are in their performance?
Okay, if I understood the question correctly, it's how many models and how we measure their performance. How big, how large is the
How large models have you ever encountered?
I don't really have a great reference. Some of the larger ones are things that do things like voice or vision, especially those models where you're doing like face identification. Those models get much larger than, for example, the motor out of balance model is actually quite small. So I can give that relative kind of comparison, but I don't have any exact figures at the top of my head. And there are starting to be some industry standard benchmarks for testing performances of NPU. There's a consortia, I believe is probably the right term for it, called EEMBC that is doing some work in this area to provide standardized benchmark tools and tests where you can compare the performance of various both MCUs and neural processing units. I don't know, Gregor, if you had any more comments?
I can add a comment to your question. In the MCU world, what we're using for models, we're actually using, we're doing pruning of the models. So if you look at what is being done by TensorFlow, we're using TensorFlow Lite or PyTorch. Basically, that's what. Actually, right now, our product, I don't know if you've seen that was recently announced, we are running the 1,000 models from NVIDIA as well. But it's really about the pruning. So actually, there is not a straight answer. It depends really on the performance you expect. We try to reduce the model to the best we can, to fit into the memories we have available. But then that's going to have an impact on the performance. Larger models can be more performance, and smaller models. But it's really pruning existing model. And honestly, we can do natural language on our product, and we can do vision. That's where I think there is really a trade-off. What I talked about again, what I mentioned earlier, the crossover with APU, where it's going to be more low power, and it's going to be more cost effective by using MCU like this or Edge. But definitely, even models like DeepSeek, we are thinking about running them also on our chip. Those are things that are contemplated with an impact on performance, trade-off, cost, performance, and size. So I think the couple of megabytes you can run good models.
Cool. Well, thank you guys. That was really great. Can we give them one more big round of applause? Hey guys, I'm Oliver Jensen. I'm the incoming president for IEEE USA. I wanted to say a couple things before we got started with the next talks. The exhibition is going to open at 10. I mean, obviously people at the keynotes don't walk around as much while they're speaking. And we'll be also opening the photo booth at 10:30. So if you'd like, everybody's here, look at nice, this is professional, this is casual. If you want to headshot for your LinkedIn, feel free to go out there. If there's not a photographer, talk to Otto or Noah Fila. They will be grabbing that. They'll take a photo. And then I'm working on a Google form. Anyway, you can fill that. It's not a big deal. I wanted to say, ever since I got into IEEE, I met Deepna. I really just thought it was a student organization. I didn't really get how big it was. And really, every day since I've been in it, it's just like it's appeared larger and larger. And I don't know, it's been people like you guys that have really showed me what this organization can do. And Matt Francis and has really, I'm sorry. Matt Francis and Jalen have really showed me. I met them yesterday. I'm so sorry.
Yeah, I'm Deepna. I'm the hospitality director. So good, so good. It happens. I'm the hospitality director for this conference. And we're here to, right now we're going to welcome Melissa and Dr. Matt Francis to speak on behalf of IEEE USA. And so can everyone give a nice warm round of applause for them? I also want to say, we could not have, this conference would have not been possible without the support of IEEE USA. They have been so helpful in getting us connections and getting us funding and making this really be the event that we visualized it to be. So we're very, very grateful, especially for like Melissa. She's been with us throughout this process. So we're very, very grateful for them. And yeah, without further ado.
So thank you again. It's been an extremely warm welcome here. We got here last night, and we're welcomed by all your the student branch leaders, the ACAPA new leaders, the new MTTS student chapter, and the Circuits and Systems, the new Circuits and Systems chapter. So it's just been amazing to be here. We're really excited to support the interest and growing community in semiconductors and all technologies that you guys have here. So my name's Matt Francis. Among other things, I am the Region 5 director. So IEEE is 500,000 members worldwide, over 500,000 members worldwide that you're part of. And IEEE USA represents those in the US, and we'll get into that in a minute. So, and I guess we have to thank Melissa Carl. She's IEEE staff in DC. And she said, she and I said, we're so impressed with what you're doing because we've been doing this for the last 2 years, setting up conferences like this, and it's not easy. You guys have done a fabulous job. I would say congratulations to your team.
Happy to be in the state of Texas. I'm a native Texas before wearing this is actually my maroon suit. I did go to that other school in Austin. But thank you for welcoming us and just the energy and the excitement that the student chapter brought to this event and just how quickly they pulled it together and just all that, you know, you should be very proud. And also too, my IEEE colleague Jalen was supporting the student chapters. If you don't know her students, meet her because she's very helpful with support for the student branch. Sure. So we just wanted to kind of tell you a little bit what we're doing in DC. It's something that Matt's kind of spearheaded throughout the country. So this is what Matt just talked about. There's a pretty picture. So we are currently in Region 5, as you know. So just know as you're, you know, one thing we talked about last night with some students, you know, Aggies are everywhere, right? Utilize your IEEE network, utilize your Aggie network. You know, I'm a University of Texas alumni. We have 7,000 in the DC area. So just make sure as you're going where you're ending up, all over the country or all over the world, just utilize those networks as you go forward. Semiconductors are very hot right now. There's lots of things. This is kind of all the areas that we work in. So we represent you in Washington. We were created to work with the U.S. government. We're a 501c3, so that means we are bipartisan, nonpartisan. We work both sides of the aisle. We work with federal agencies. This is just some of the many issues that we're dealing with right now. So we need your input. We represent you. There's lots of things we can talk about later. So again, around since the 1970s, these are some of our priorities for this year. So if you haven't heard, we have the Nick College Professional Business Day. It's actually next week. Matt will actually be coming up to DC. But this is kind of what we're talking about with support for your federal technology initiative, support to fund the institutions like Texas A&M, University of Texas, Brigham, things like that. So please make sure that you're aware of what's going on. And also the small business. So for the small business owners, how you can be supported, you know, all the different rounds.
So I think we have over 40 coming from the state of Texas alone,
Yes.
from Region 5 next week. So.
But there are ways to participate not in DC, we'll tell you about. So as you know, the CHIPS Act has been around. So it's currently under review. That's why it's currently under review. So this administration will definitely put its priorities together and figure out how. But there's a lot of money expended. There's a lot of accountability needed. Some of our federal officials, like Chris Hill from NASA in the room, like things are going on. So things are going to be going on. Things may be changing somewhat. But that being said, we are here to help the federal agencies, especially the U.S. government and our members, figure out how to propel the semiconductor industry on this side. So again, under review right now. Stay tuned, but a lot of money is already spent. That being said, if you saw earlier this week, the Trump administration announced a new office to kind of help with that. So definitely stay tuned on that and see kind of how that is going to go through the rest of the Department of Commerce. So there's a lot of money in different places. Matt King has a small business owner tell you a little bit about that. There's different pockets of money to look for. So this is the CHIPS one.
So yeah, so this just shows some of the investments that were made under the CHIPS Act, and you know a few of those happened in Texas. You notice, and so we've got some basically major investments in not just fabs but in R&D. We'll hear later this afternoon about the NGM Center at DARPA. It's actually where I started my Texas tour this week, was there. I was at a DARPA review at UT Austin. As was during the introduction, we talked about this, there's been accelerating what was already, in some places, what was already happening. So Texas has always been at this, one of the, heartlands of semiconductor. You have Silicon Valley, this is the Silicon Prairie. But we're also seeing a lot of investment across the country, and I'll talk about this later, because the supply chains are really complicated. It's not just the fabs. You've got the packaging that goes into it, you've got the equipment, and you've got the materials. And so that's when you see the different colors, all the different investments that were made. And so this is a chart that our president, Tim Lee, this year's president, Tim Lee, who really wishes he could be here. He is so thrilled with this event. He's an engineer at Boeing and a great colleague on this. So there's been a lot of different hubs and programs created over the last couple of years. IEEE Commons is one. This was the defense part of the CHIPS Act. This is already pretty much funded. And so these different hubs around the country were created to collect together essentially the lab to fab infrastructure. So the idea of these hubs is that you can have an idea for technology and not just be limited to design, right? You can try new materials, you can try new topologies, you can try new packaging. And so I'm really thrilled that I've gotten to participate in the Silicon Crossroads hub out of Indiana. There's the SWAP hub in Arizona. There's 2 hubs in California. And then of course there's the grouping of Northeast hubs. We did some events around these last year that were really highly successful. Over the last 2 years, we did an event in California that was designing chips with chips. That Qualcomm actually hosted us on their campus, and then we did a packaging event. Here you see there in the middle in Phoenix. And these are the this is part of what we call our iWork series. It's Innovation Workforce Research Conferences. And so these have been where we collect people together on topical items in different parts of the world. And speaking of which, here are the other iWork events. The first of these events, and this is how I got involved in setting up these kind of events, was happened to be in Little Rock, Arkansas, where I'm actually from Northwest Arkansas. We've now taken that to Alabama. We've taken that to the Dakotas. Our next one's in Maine. Is that correct?
We're on Maine, May 15th. I know it's a little bit further from Texas, but if you're around the Northeast, let us know.
And so, and I just mentioned this one already, as far as investments related to chips. DARPA NGM, this is over $800 million advanced packaging, next generation materials. And this is in Austin. It's an impressive facility that's being set up right now. So let's see. So there were also through EDA, not Electronic Design Automation, what this audience would think, but the Economic Development Administration, there were tech hubs created, and these focus on different emerging technology areas. So these are all hubs that were funded around the country. They range in anything from autonomous systems to quantum to safety systems. It's a very broad set of hubs. And so there were also investments in this, and you can see some of the investment. There was a hub created in Texas. So I think with that, we're going to talk about what this means for you, because we're here today for you as students looking at your next steps, whether that's in research or development, in industry, or academia. And so, what we're still seeing is that, despite the economic conditions, there's a continued need for people that have semiconductor experience. We continue to project the Semiconductor Industry Association is one of the groups we work closely with, that by 2030 we're going to have over 100,000 jobs that are going to need to be added. And so semiconductor is a great industry to get into, and I think we're really set up well before this conversation with the presentation by Stevens It's everywhere. Semiconductor is everything. And I think what's exciting for you guys is that every job is turning into a tech job. And by being in semiconductor, you're being really at the forefront of the technology and implementing it.
So this one's just talking about the different, it's changing quickly. But TSMC also, just a little bit ago, responded to President Trump bringing more investment. And then you also hear on the flip side, they don't have enough workers, they don't have the right kind of workers, stuff is delayed. So this is really where you come in, and this U.S. students, as you're looking for jobs, make sure you get those skills, have that training. And this will also tell you about in just a second on how IEEE can help you through some of our other educational initiatives. So there is a website, also on the website, talking about our different partners, including kind of jobs and information, things like that. There's groups that you can join at the local level, at the regional level, at the national level. So, again, everybody's so busy as a student, I don't know how you'll do it all these days. But that being said, if you have a strategic focus, figure out something that you can really join and think about your future.
This one I would like to speak to, so you might recognize a face up there. So I said, we're all in this together. So, I ended up in the semiconductor industry, but I didn't know what it was. I barely knew what it was when I was in college. I didn't really understand it until I ended up working at HP. And so one of my passions is to make sure that kids, as young kids as we can, understand what the semiconductor industry is, not just that it's computers. Like literally, how do we make these things? That's the cool opportunity we have because this has come to the forefront, right? It's a topic. Okay, 5 years ago, you'd say semiconductors and people would be like, what are those? Everybody knows what it is now. And so we developed these on Semiconductor, actually made several generous donations to help us support, create these. We created an ebook and videos and a whole curriculum for middle school teachers so that they can expose students to the concepts of semiconductor manufacturing. We actually use Play-Doh to make wafers. It's so much fun. We've now done 3 sessions last year. We're doing 3 more sessions this year, and we're working on a video game, a semiconductor manufacturing video game. So if you want to get involved in this is tryengineering.org/semiconductors. Check it out. Contact me. I think this is a wonderful thing for students and student branches to get involved in. We can help you work with local teachers in your community and teach this.
So same, just definitely check the website. It's constantly being updated, and get you good information. So just let us know how we can do it. Also, micro-credentialing has really started to get more activity, currently partnering with USC. So, again, you're getting your undergrad degree, you're getting your graduate degree, but as you're thinking about what you need credentialing-wise, if you've been in the workforce for a while, there may be a sample of micro-credential that might be of interest.
So yeah, like the lifelong learning. So does anyone think technology is moving slower? No, right? We're all like, wow, this is one of the tools that's going to continue to evolve. So think about that. Like I said, you're not done learning when you graduate. So we're one of the institutions that can help you with your lifelong learning journey.
All right, and so this is just some of our policy activities, and there's a lot of it more that's on our website, and there's a USA part of it, so it's actually USA.org. So just check it out, what we're doing. We're in a lot of coalitions representing the industry, working with the other engineering groups. We're trying to do the grassroots as we're bringing watching next week. We have over 300 people. I think the most we've had today has been 200. So we have 300 people coming. Again, it's a unified message. We work bipartisan, nonpartisan. It is a policy message. So your staff in DC understands the politics of what's going on or tries to, but really works the policy around the politics. And so that's what you should take.
So you guys are a hot commodity with lawmakers because you actually understand how the technology works. They need help, okay? And that's how they set policy. And there's also this ICOP program, which flips it around the other way. And we set up things, opportunities for you to meet with state lawmakers. And so there's actually going to be one in Texas here, I think, next month. So, these are, let's say, the USA website's got a ton of great information on it.
Same, this is just the global semiconductor website. So just check it out. It's perfect.
Everybody got it?
And same, authorization, this is when Congress says this is how much money should be, and then appropriators say this is what you're going to get. And so that's another way that our office works, is trying to get those appropriation numbers as high as possible to give the appropriations to media. So this is a riff off John F. Kennedy, so that's not what I can do for you, but what can you do for IEEE? Here we go. All right, so there's 3 very short-term ways you get involved. We'll definitely let the folks or the student organizers know about this event in May. So this next month in Austin. So if you can't come to DC, come to Austin, check it out. It is a young professional early career and student event. My colleague Annie Perrin Grisham will be in town, or close to town in Austin, so check it out. Also, if you can't make it to DC or Austin, you can participate in committees, lots of different committees, all the issues we talked about in AI, lots of energy issues, semiconductor general issues, things like that. Just let us know how you want to be involved. We want students involved. We want that student perspective. We want to know, how does this research funding work? Is it working? How should the authorizing? There's lots of things that we work on. IEEE USA helps draft legislation. Again, working with both sides of the aisle on that, and gives comments to the administration on that. So we want to have good technical input for all this. And IEEE is your professional hub.
And so here's some highlights from, these are some highlights from CBD last year. So it was incredible. We actually got to meet in one of the Senate office buildings. This year, we're actually doing our training at the Spy Museum, which is really cool. But he said, you can see, so I was really excited. I actually got to meet with one of my senators, Senator Bozeman. And so most of the meetings are with staff, because they're actually the ones that actually make everything happen. Sometimes you bring a big contingent, you actually get to meet, have some time with your member. But it said they really love having young people there, because like I said, you guys are creating the next generation of technology. You're going into your next stage of your career. They want to hear what your concerns are, what your ideas are. And I said, this is all, like I said, the government's all our government. We're shaping policy. And what's really powerful about USA is we bring the largest groups of technologists to the Hill of anyone in the world. And it's just incredible to see. So this is next week. So too late to register now, but know that it's at Hill.
Spoiler alert, it happens every April.
It happens every April,
If
yeah.
you want to come up next year, we'd love to have you. Also, Matt was telling me last night, one of his members said, oh, that's Matt Francis. You're the...
Oh, Arkansas semiconductor expert. When I walked in the room, I was like, oh, that's nice. So you make an impression, so it said you can make an impression. I've been doing this for 5 or 6 years now, I'm starting to lose track. But yeah, they're all just people, they're your representatives, okay? They're there, you can walk in and you can talk to them, and we will help you have that conversation and teach you how to do the ask, the way that they have to think about building laws. And that's what's tremendous. The USA staff, I can't speak highly enough of what they do. Great, fantastic people. They give you a voice.
These are just the numbers again, over 300 people next week, so please come soon. And this is our social media. Hopefully you're all following it. Hopefully you're tagging us in your social media for the day. We're so excited to be able to support such a great inaugural event. Again, I always say we never count out what students can do. The fact that they pulled this off so quickly, and just the professionalism of this event should be highly regarded. So kudos again to the student branch.
Hey guys, we have time for just one question. So does anybody have a question? Oh, cool, perfect.
And we'll be here all day.
Yes.
Howdy, my name is Zayna Fees. I'm a first year engineering student. I also work as a sales engineer for Safran Executive Consulting. And my question is, what would you say the projected growth is within individual investments within semiconductor manufacturing? And will there be a lot of government regulation within this CHIP Act with semiconductor manufacturing?
So that's a long question. So I think it's too soon to tell. I mean, again, it's not even 100 days into this administration. So what I would say is, need to be kind of cognizant of what's going on, that it's kind of changing on a daily basis. So what I would think is just, we'll look at the long game for that, because I think that's kind of what matters, and as you, work with us and other groups in your employer to really also, there are like myself, front row, professional staff members at these agencies that do also have a pulse of kind of what long-term trends are. So I would say, if things are gonna change, DC, I love DC, I lived there for 26 years, so like when we leave occasionally I come to Texas, because DC's not always the real world, because, we have a short attention span.
All they make is laws.
Yeah, so, we don't actually make things, but, DC also has a short attention span, so even if the Trump administration maybe had not, wanted to do the changes, members of Congress would, because that passed in 22, which meant that they started drafting it probably in 2020 and 2021, and in DC time, that's like 5 years. So I think the main thing to do is just, there's always a saying in DC, if you don't participate in the conversation, you're lunch. So definitely participate in the conversation. So I would say that, we are very cognizant of what's going on. I think that there's going to be different changes. It's too soon to speak to. I mean, whatever the party, DC does like to regulate. That's why your voice is important, because people don't actually understand. Like my mother, elementary school principal in Fort Worth, Texas, during No Child Left Behind. So she was given a CD and said, implement this. And my mom, who was a 39-year educator, just kind of laughed and said, oh, I'd love for my students to do X, Y, and Z. So I think that's what you have to be part of the conversation. She did her best, but again, spoiler alert, not all students, met their targets in 5 years, because, they had other things. But I think that's why we constantly have to be having a conversation. It can't be a one-off. These meetings typically start with 15 minutes, but then, Matt gets contacted by his representative and says, hey, Matt, I'm drafting this bill, I'm drafting this this amendment. I'm also, the administration wants to do this, what do you think? And then you're part of the conversation.
Yep. So the next thing you know, your comments are in a hearing on C-SPAN.
Or you get to be a witness at it.
Yeah. So and that's, I think Melissa hit the nail on the head. It doesn't matter what your major and what you do, you should be part of the conversation and represent your field. And it's not just for political science majors. And so I've been involved in lots of organizations. This is a very unique part of IEEE USA, as you as a member in the US can take advantage of, and so we also do it at the local level. Like we will, if you guys wanted to organize an event with your representative, we could do that and have them come to you. We've done that before. So just think creatively, reach out, and said, let's foster the conversation. We're working together to how we make everything better.
And last thing I'll say, I was at my previous job, I worked with account vendors for a while, and I had this wonderful researcher say, well, I just want to be in the lab. I mean, unfortunately, those days are over for unfortunately faculty and even industry. Like, you have to be cognizant of what's going on, especially with research funding and kind of why how to continue to have it. So I think that's why just be part of the process. It can be frustrating, but it can also you get these big wins. Like the CHIPS Act was a huge win. It's something we've been working on for 10 years. And so just know that whether tweaks come and there's challenges, there's always on the other side.
Well, so I think that was our cue to get on stage. Thank you.
Thank you, Melissa and Matt. So that train, you can hear that. Welcome to College Station. Next, I think we're going to. So the exhibition is going to open up. We request that all attendees head out to the exhibition after our next keynote by Robbie Williamson from ARM. So can everyone give it up for him?
Oh boy, howdy. Howdy. As a UT alumni, I don't know how hard that was to say, but my sister went to here, so I don't have too much empathy. I'm actually wanting to go to you. So I was given this topic by IEEE, which is actually pretty cool. I know it sounds pretty boring, but I tried to make it pretty exciting in terms of how art plays a role in this. And it's a good fit for what I do actually. My background is software engineering, but I've worked in the silicon industry over 20 years at least. Started at IBM, worked on risk processing, server side. Did a short stint in software for a company called Canonical that makes Ubuntu Linux. Ran all of their software engineering, a lot of OS development on silicon and on servers, and mostly in the cloud. And then I joined ARM. Let me go to. So, silicon to solutions. I'm just going to go real quick here. So, how many people by show of hands know who ARM is? Okay, now keep it up if you know exactly what we do. Yes, that's all good. So, first of all, I know we just went public a few years ago, but we were public before and did SoftBank audits and private a little bit. ARM is over 30 years old, right? And we were born to run off batteries, right? Born in Cambridge, United Kingdom. We still have a large presence there. We have a large presence in Bangalore, Austin, Texas, and numerous other places around the world, Shanghai. We are everywhere, right? These numbers have already changed, but 99% of smartphones run on our technology. 99%. I think we were just afraid to say 100% because there's got to be some crazy phone around our wrist processor or something. But 70% of our population are using our products. We have over 9,000 employees, actually over 10,000 as of yesterday when I checked, around the world. And we've shipped over 280 billion, well, we have, of course, our partners have shipped over 280 billion chips based on our technology. But that didn't really explain to you exactly what we do, right? So what do? We do not actually make anything physical. We sell ideas. We're IP company. What does that mean, right? So we sell ideas around various processing technologies, CPUs, GPUs, NPUs, TPUs, all these PUs, right? They're just processing units, right? And IP is particularly around interconnects as well, and we sell that to a ton of different companies around the industry that they take and they build products. And we make our money out of licensing and royalties. So it's kind of like music business in a way, like IP. So there's initial sale, you buy your IP, you create your product, you have different scales, different levels. And then depending upon the industry and the commercial agreements, every time you sell one of your products, you get a cut. Sometimes it's literally pennies or cents. Sometimes it's a lot of dollars. Not covered up quickly in terms of that. But this is not playing a good size. We are everywhere. So I'll cover it really quickly from edge to cloud. IoT industry, because we were born to run on batteries, right? We are traditionally low power, high performance. So in areas where power is constrained, we're a perfect fit, our IP. So a lot of our processing technology is used at the edge. Infineon is a partner. Simple edge devices like a thermostat, or even complex things like edge-based cameras that are doing vision control, or say security, or even like the trains when they have cameras on the train track to see, to make sure there's safety going on. They can adjust as they detect incidents. Moving up the stack, we're in mobile. So as I said, 99%. Apple was our biggest, one of our huge kind of monumental partners early on. The first iPhone was ARM-based, right? The ARM-based IP is in Android or iPhone, so it doesn't matter, right? Whatever kind of phone you got, we're in there. And it's the reason why your phone doesn't need a fan. I guess it gets hot, especially these days. Some of these phones burn your leg. But typically, the reason why our technology is applied in the mobile space is because, again, high performance at a low power. Later on, I'll go into some of the AI applications that we use. PC, so you're thinking, Qualcomm, okay, big deal, like that's a small percentage of the market, I guess you're a PC. But up until recently, we weren't allowed to talk about it, but we are now. I saw it on LinkedIn, our CEO approved it. But the Apple silicon, that everyone's heard of, right? The new M1, 2, 3, 4, right? They rock, right? That's based on ARM IP. Right? Apple owns an architectural license. There's different levels of things that we sell. I don't want to get too far into that, but they take that license and they create their IP. And so every time there's an iPhone sold, we get a cut. But at those numbers, that iPhones are sold globally, it's big money. Same with the MacBooks and the Airs that you get on the end class, right? The end processor. So we are actually bigger in the PC market than most people realize because of Apple and the benefits that you get on their silicon. We're also pretty big in China. There's a big market out there as well that makes ARM-based laptops. Moving up the stack to auto. Now, auto and IoT used to be kind of a similar market for us because of the sensors in your cars that detect everything from if your door's open to you're about to hit something. But now with electricity and electrified cars, it's become even more important to be power sensitive, right? Because not only now you're draining not just the power from your battery, but you're draining your fuel, right? How far you can go. So sensitivity to power is even more important to car manufacturers. And in the auto space, there's way more technology now. Some of the IP that we're looking at now that's selling to the auto industry that we also use in our server side. Like basically, some of these vehicles are having small servers in the back to do all the calculations they need to, not just for driving, but also for your in-vehicle infotainment systems and all the lights and all the new stuff that you see nowadays. We're big in auto, huge, and we're pretty dominant in that space as well. Partners like NVIDIA are huge in there. In that space as well. And then infrastructure, cloud, funny small note. Because I work in the infrastructure line of business, sometimes people look that up on LinkedIn and recruiters think I work in like infrastructure, like concrete. And so I get recruiters asking me about, if I want to go build buildings. In the infrastructure space, we were relatively new. I'd say that journey started around 2012, 11, when we started looking at could we enter the cloud data center space, primarily dominated by the x86 architecture, primarily distributed by Intel and AMD. We had some false starts and stumbles along the way, but around 2018, 2019, we really kind of settled in on our IP that was able to reduce the level of performance you expect at a server, but still at low power, right? And the first real major deployment of that was the Amazon Graviton processor, Graviton 1. Now we're up to Graviton 4 with Amazon. They love that processor. It is price per performance better than anything else that they provide. With the growth of cloud computing, data center computing, and the cost of electricity and some of the restrictions, and especially in Europe, being able to provide large amounts of compute, but with low power, is an advantage for us and an advantage for the provider in terms of savings. Not just on electrical, but also cooling. Right? These processors are getting hotter and hotter. Some of our competition, you have to have water cooling for some of these, liquid cooling for some of these data centers. And there's a cost to all that. And so from a sustainability perspective, environmental perspective, there's a lot, and even a regulation perspective, they're looking for ways to provide more computing with less power. And it was like a game changer for us, right? And that's why you're seeing NVIDIA, one of the reasons, one of our major partners, doing so well, along with some of their investment in AI, which I have a slide on because everyone has to have a slide on AI these days, so I'll get to that. But that's where we're at. We are everywhere. Our IP is everywhere. We participate with our partners in the ecosystem to help them to be successful. And I'll kind of dig into that as well in terms of not just engineering, but the business side, and what do we particularly do in the area that I work in, right? For all these areas, ARM has a line of business, or a business unit. Our mobile and PC are combined, so basically an IoT client, auto, and infrastructure. And those lines of business work with our engineers and our to package our IP in such a way that meets those industry needs, and then we work with our partners to build their products, take them to market, and make them successful, right? So it's a whole end-to-end solution, engineering all the way to getting these things to make us money, right? Because the licensing is great, but it's really the use, the royalty. So we have to make sure our partners are successful in order for us to really make the money that we looking for. I'm going to dive a little deeper into the one I wrote in, so I noticed the most, but I can talk to you. You can ask a question about any of the lines of business. These are the smaller segments that we break down in infrastructure. This is a kind of a dated slide because you don't see AI there, and that's a huge segment now, as you can imagine. Again, so I gave it its own slide. Cloud and data center, wireless and 5G. So not just at the tower end level, right? We have smaller IP that work at the base stations, at the antenna level itself, but with edge computing and a lot more demand for computing near your end device. I actually spent some time at a 5G edge company for a while. Now telcos are looking to deploy many data centers at the base of the tower, right? To offload compute there, to do localized compute, AI training, AI inference. That's a big deal. NVIDIA's actually getting into the industry. So it's a unique time in the telco industry because there's a big blur going on between this industry and this industry because you have likes of Amazon deploying edge computing infrastructure. So there's like a lot of battles going on here. Networking edge networking devices. So you think of our partners like Cisco, who create complex routing security devices, deploy to the edge. You have partners like Cloudflare. Have you heard of them? They're a CDN company that allows you to offload data closer to your endpoints. Netflix, for example, uses those type of services to make sure their content is closer to you versus having to go all the way back to Amazon for data center. And HPC is a niche market, but it's one of those high performance computing is one of those areas that there's a lot of computing discoveries done there. It's not very big in terms of overall addressable market, like revenue-wise, but it's consistent. A lot of government money and university money goes into here. A lot of breakthroughs that start there, feed into the rest of the industry. So we do have our foot in that area as well. A lot of that is still done in data centers, but there's also a lot of it moving into the cloud for cost reasons and accessibility reasons. And so AI. I do a lot in this industry on AI from the standpoint of the silicon as well as the software solutions. So solutions engineering, which is an area that I have a lot of solutions engineers that work for me. What is a solution engineer? It's kind of a jack of all trades and master of none. You can't really go to school to be a solutions engineer in terms of like, I want to major in that. But I have, electrical engineers, computer engineers, software engineers. I have folks who've done even investigations into neural networks. It's a hodgepodge of ninja-like skills that you develop over a career to become a solution engineer. Now we do hire grad hires, we do hire folks into our organization. Typically, and then we have like a funneling system of how to start in one area and kind of depending on your strengths and your interests, we start cultivating that to what you're interested in. It's a pretty cool job, to be honest, if you like change, right? Because we're, in terms of solutions, we're always asked to look at something, make it work better, figure it out. It's constant learning. A few years ago, we weren't even talking about AI. We were like, we got AI down. Machine learning, we're good. We're really focused on the metaverse. That ended really quickly. But AI is something that we work on hugely right now in terms of understanding workloads, where they are best ran. Are they best ran on the CPU or on an accelerator? What does that entail? Obviously, our partners like NVIDIA, who sell the Grace Blackwell, which is a combination of an ARM main CPU and an NVIDIA designed GPU. They're printing money on these things, on the Grace Blackwell, Grace Hopper. They can't make enough. These things are used primarily for training models at large scales. GPUs are very good at certain types of calculations that allow you to train efficiently. CPUs are more general purpose, right? So they're good at orchestrating the compute, but that's why they get paired up. So we work with NVIDIA, we work with other partners to understand how workloads are best utilized in their products. But we also work with Google Cloud, Microsoft, and Amazon, me personally actually, on taking advantage of their ARM-based silicon. Amazon, all these clouds obviously deploy NVIDIA in their cloud for use, but those are expensive. And so they even want to know what workloads can they keep natively on their own CPUs, be it Graviton, Axion, or Cobalt 100, to run smaller training models, smaller inference, and save the big GPUs for selling to partners, customers, just being efficient with AI. AI is, you might as well just call it computing at this point, right? Like everything uses artificial intelligence from one thing or another. It's not just like ChatGPT, right? It's like the recommendation on your phone as you type, right? Like there's even innovation going on there in terms of how much local AI you can put on your phone so that you can do some level of small language models while you're disconnected. I would say that if you're in technology, you should be aware of AI now and how your particular field plays a role in it, because it is big. Now, there's a lot of buzzy stuff going on. There's a lot of, oh, I can be a prompt engineer. I mean, that's not going to last very long. But if you can make money on it, go for it. But it's like being a search engineer back in Google's, right? I'm old, by the way. I'm 48, so I remember pre-Google. So again, we are neck deep in the AI industry, but it's computing. It's just the next evolution of computing, and ARM's always been involved there. So my day-to-day often involves AI at some level. And again, I would just recommend for any of you students that you should just understand the industry of AI and what it is and all the different things. What does NVIDIA do there? Why are they so successful? What is DeepSeek? Why did that make such press in terms of why was it so revolutionary? Why kind of not actually get into it. One of these type of questions, like talk about this, right? I love this stuff. So ARM Neoverse is our brand for the infrastructure space. Something like you can think about, Pentium for Intel, that's old Xeon. And again, ARM is an enabler, partners enabler of ecosystems. We don't exist without working with partners, because that's the only way we become successful. Every logo on here, this is not just a logo slide, it's someone we work with at some different level within the infrastructure line of business, my line of business. SoCs, silicon chip. We've designed customized CPUs and accelerator IP with all these companies, both in Europe, US, and China. DPUs, data processing units, that might be a new term for you. It's basically, a DPU is a mini computer on a PCI card, or basically expansion card that you stick in a server that allows it to manage numerous things for the server internally, networking traffic. It can do a little bit of management of the actual machine itself. Huge hyperscale data centers like to use DPUs in their servers because it allows them to free up as much CPU in the main server to sell. So in Amazon, they have a proprietary designed DPU called the Nitro card. And that Nitro card sits in every server within the Amazon cloud and manages all the day-to-day, the management of the server itself, so that the CPUs inside the server can be sold as VMs, virtual machines, to users. And every cloud provider does this now. Every data center, telcos do it as well. So it's a good way to kind of take advantage of the most compute in the larger servers. And then we have partners that actually build silicons, build servers, and so forth. So one of the things that's also important is that software is important. My last slide, so I can take some questions for you guys. I'm trying to rush through this. I'm a software guy, so I got to plug this a little bit. But the ecosystem that ARM provides is another thing that we've done over the last, say, 20 or so years in the server side to allow Hardware is important, but it doesn't work without software. Sorry to say it, right? The hardware is necessary, don't get me wrong. Like, some of the key things going on that we're designing for AI are necessary. If you heard about the Stargate project, you can Google it. We're working on that now with Oracle, some other partners for a massive AI farm. OpenAI is involved. Hardware is important, but all that doesn't matter without software. One of the reasons why NVIDIA is so successful is not just because of their hardware, it's because of the CUDA software ecosystem, which allows you to migrate models. It started out actually as a graphics model application software, but we work across the stack. I have to work with a ton of software companies to make sure that their applications run on ARM platforms and run well. A lot of the server space was dominated by x86 architecture, and so we have to work with partners, take that same code, help them optimize, help them get performance. So in order to take advantage of silicon, take advantage of hardware, you have to have software as well. So these are the areas we're hiring. We have a little booth out there. Software engineering, hardware engineering, applications engineering. These are areas that are big that you'll see a lot in our recruiting. We are growing rapidly. When I joined the company in 2019, we were barely 6,000. Now we're over 10,000. We are aggressively growing to meet the demand of AI in the space and what is put across all of our industries. If you go on our website, careers.arm.com, you can find tons of jobs globally. We'll pay for your relocation. We do have hybrid working. That's not going to say you get to work from home every day, but it is allowed in certain circumstances and promoted in some others. We have internships. Now it's kind of locked down for this summer. Typically we start that in the fall in terms of interviewing candidates. But I think I'll end with this. Like, the importance of an internship in this industry is critical. Like, I started my job in software with an internship at IBM. Right? I'm old again, so like 1999. But not only does it like get your foot in the door with a company that you end up working with, it's a great way to obviously get a feeder because we will hire our interns, they have experience. But it also gives you a lot of real world experience that you're just not going to get in school. And it's a way to stand out. Like, you've got to have, if you're trying to go get a job after undergrad or grad, get an internship, get a co-op. Like, don't discount that. It's so important. I can't stress it. I mean, it's so important. Like I said, school prepares you with the basics, but when you get into the industry, you're like, oh wow, like your eyes are wide open. We have so many grad hires who are like, oh, I didn't even know, how much this is advanced or how you guys do this. Like, it's okay. We expect you not to know anything, but if you have an internship, at least you know you're not going to know anything. And I'll wrap up now so I can take some questions, keep this on time. Is that good? The sales engineer is going to ask a hard one.
All right, let's give him a round of applause. So we have time for one question, please.
I'll be around for, you'll find me, I'll be
Please
around.
stay after and talk with Robbie. But any questions?
First year computer engineering graduate and sales engineer. I'm ready.
So, as owners of the website selling IPs, how threatened do you feel by RISC-V and open source community in general?
Good question. Two different things. So I'll repeat it. How threatened are we by RISC-V and open source in general? One, I'm a software guy. I grew up in Linux. I'm an open source advocate. Totally believe in software and open source. I've seen life before and after. Game changer, right? I actually grew up in a time where at IBM, I was told to make Linux enterprise ready, which is a joke now, but back then it was a real investment. I think RISC-V has its place, specifically in areas where you control more of the software stack, the ecosystem. The biggest thing and ARM went through this before, and this is why we stumbled so many times in the server space, is that it's the software that matters. RISC-V is not an architecture, it's a specification in a sense. So the problem that you run into with RISC-V going into the server space is that there's no guarantee that how your software is going to perform because you don't have to, it's a specification that people can choose and pick from. That kind of works in open source software, but in the hardware level, for example, I may not know the vector name that you decided to put in your RISC-V processor compared to this one. I write my software expecting to be 128-bit, you have 250. It's like there's so many different issues that run into because of the flexibility if you want to use in the server space, right? Because it has to be software developed independently of the hardware. But in like the smaller industries, auto, IoT, spaces where you control the whole software stack, there's a place for RISC-V. There's a place for that when it's not really about interoperability as much as the software level and ecosystem. I know I think in China there's maybe a bigger chance for RISC-V to be successful at the high level because they can actually mandate a specification that everyone has to kind of apply to at the manufacturing level. But we talk about RISC-V not really as a big boogeyman, but as in just another architecture, another specification that we just have to work with. We even have partners that will take some of our IP and marry it with RISC-V in terms of how they have certain, maybe a CPU is ARM-based and their accelerators RISC-based. When it first came out, there was a lot of marketing hype around it, but it's kind of settled down into reality where there's going to be a space for it, just like everything.
Okay, can you all hear me? Yeah. Okay. Thank you, Rami, for that. Can we give another round of applause? Alright, so what we're going to be doing now is, the exhibition is fully open. There's some really cool things out there that we even want some of our speakers to go and check out. So if everybody could actually head to the exhibition in an organized manner, just right through here, and then also there's an entrance right through there. Now's your chance to kind of get up, stretch, and all of that. And we will be starting again in 20 minutes with Dr. Matt Francis. So we'll keep you all kind of updated on time and all that. Thank you.
Really?
Like all night long. And I woke up and was 5 minutes away from it.
It's the worst thing to do. That's the worst thing to do. I mean, sure, it's a solution. I mean, there might be something you don't specify, and then